Good morning, everyone. Aloha and welcome to day 2 of the Women in Space Exploration Talks. I'm so excited to be here with you today. My name is Mimi Fuchs and I love science. I've had the good fortune to work on the Mauna Kea observatories for the last 5 years and work with Pisces in some of their outreach engagement. We are so excited to this week be featuring a variety of women working in the aerospace industry. Before we get started, a big mahalo to Pisces for organizing this very exciting program. And a big thank you to our sponsors with Microsoft and the Hawaii Science and Technology Museum. Today, we are really lucky to be joined by Nagin Cox, who is going to be speaking with us today in the form of a 30-minute presentation, followed by a 30-minute question and answer session directly afterwards. Remember, this is an event where we want to encourage all of your questions. So if you have questions, start posting them in the chat or write them down so you can get ready to put them at the beginning of our question and answer session in about 30 minutes. So let's get started. Today we are really excited to be joined by Nagin Cox, spacecraft operation engineer at NASA's Jet Propulsion Laboratory. Nagin Cox has known she's wanted to work at JPL since she was a teenager. She's had a really exciting career over the last 20 years working at JPL, holding leadership and system engineering positions on interplanetary robotic missions such as the Galileo mission to Jupiter, the Mars exploration rovers, the Kepler exoplanet hunter, InSight, and of course, my personal favorite, the Mars Curiosity rover. I saw it launch years ago, and for anyone who's seen some of these crafts be launched, they know how exciting it is and how much work goes into these missions. So we're very excited to learn more about what goes into that and learn a little bit more about Nagin's career path and how she got to where she is. So without further ado, I'll hand it over to our presenter. And as I said, she'll be giving us a presentation, and afterwards we'll have some time to ask her some of our most nail-biting questions about what it's like working at JPL. Without further ado, Nagin Cox.
Aloha, can you hear me?
Yes.
Excellent. Thank you so much, Mimi. That was, I'm really excited to be here today. Let me bring up my slides for you here. So it is a real privilege to be with y'all live from JPL, from NASA's Jet Propulsion Laboratory in Pasadena, California, to talk to you a little bit about some of our space exploration missions. And if I can keep myself from telling too many stories, then hopefully we'll have time to chat after. But given everything that's going on right now, we're going to focus a little bit on these Mars missions. But we can talk about careers and STEM and space and whatever you'd like after I give you just a little bit of background about what's actually happening here right now, even today. And that's why I'm wearing my mask, as I'm actually right off of the mission control area, and we're busy doing a rehearsal today. So I will talk about that when we get there. All right, so let me get started. As Mimi went through, I've been very lucky to work at JPL on a number of different deep space missions, something that I've wanted to do since I was a little girl, and we'll talk about that more near the end. So just to give you some background, I am actually sitting in, this building, this building here today to work on Mars operations, and that's at the Jet Propulsion Laboratory, Pasadena, California. And we're actually a part of NASA, but we are run for NASA by the California Institute of Technology, or Caltech. So our job is the robotic exploration of the solar system and beyond. You've probably heard of different parts of NASA, like when you think of the launches, probably think of the Kennedy Space Center in Florida, and the Johnson Space Center in Texas is where the astronauts live and train. But in Pasadena, we focus on the robotic exploration of the solar system. So before we send people, we send robots. And that's so we can get to know what a place is like, make a map, send an orbiter, really find out what a planet or a moon or a celestial body is like so that we can later send people and also so we can learn about our solar system beyond just our Earth. So we started robotically exploring Mars back in the 1960s. And there was a time when this picture had just a few flags on it. It was primarily the US and the Soviet Union that were busy exploring space. And every time I get a new version of this picture, I just love that there are more and more nations involved. In fact, this year, this summer, just a month ago, when we started launching missions to Mars for this opportunity, we had not only the US launch, but China launched, and the Middle East for the first time is sending their own orbiter to Mars. So when we visit Mars, which is our nearest planetary neighbor most of the time, we either send an orbiter like this group that you see here, and these are craft that go into orbit around Mars and really find out what the whole planet is like. But we also send landers and rovers because to really get to know a place, you often have to get down and close to it. You have to land and drive around. So I've been lucky in my career to get a chance to work on these rovers to Mars. Our first rover we sent in 1997 called Pathfinder, and then Spirit, Opportunity, and Curiosity are the ones that I've worked on. Spirit and Opportunity were twin rovers that went in 2004. And they were the first ones to really drive around on Mars and find out what was Mars like. And we discovered that there was once water on Mars, water that existed at the surface. And that was really big to find out that Mars was once more like the Earth. So then we sent Curiosity, and Curiosity is still there operating on Mars, and her job was to find out, well, was Mars really once like the Earth? Could it have had life? Was it habitable? And the answer to that is yes, Mars was once much more like the Earth, and it was due to these rovers that we know that. These missions always learn from the prior mission. And when we started out, every mission stands on the shoulder of the prior mission. And Curiosity learned from Phoenix, from Spirit and Opportunity. And now here we are in 2020 and the recent launch of the Perseverance rover. So you can see that this is a campaign of exploration. And this is true of any great endeavors that we do in almost any industry. We don't do things alone. We learn from what we did before and stand on the shoulders of those who came before us. Curiosity is the rover that is currently on Mars, exploring and has been since 2012 when we landed her with the objective of finding out if Mars had once been habitable. We knew there was water there from the earlier rovers, but now the next question was, how long was the water there? Did it actually create an environment for life? And Curiosity, after exploring since 2012, we know the answer to that is yes, that Mars was once habitable. That's not the same as habited. We have not found any evidence of life on Mars in the past, microbial life. But it's like pulling back a curtain. The more we look, the more we find out how the building blocks were there, the pieces that are needed for life. We find indications that those were there on Mars in the distant past, a long time ago, billions of years ago. And that raises the question, why did Mars change? How is it different now? Why is it different now? So the next rover, the Mars 2020 rover, now called Perseverance, actually launched last month, or more than a month ago now, in July of this year, July 30th. Her job is to get to Mars and really try to start answering this question of, we know Mars had water, we know it was once habitable. Was there, in fact, microbial life? Curiosity, who used to be called MSL, and Mars 2020, now called Perseverance rover, they're very similar. They have a lot of functional similarities because we wanted to reuse what worked in the prior mission. But we have more cameras, we have better wheels, we have stronger robotic arm. We keep improving for the next objective. So here she is, all set to go in one of her first driving tests on the Earth. This is a picture of the Perseverance rover doing her driving tests in our clean room, which is that way from where I'm sitting here at JPL. And this is where we put the rover through her paces, and you'll see that she's in a clean room where the workers are wearing bunny suits and masks, all to make sure that there's no contamination where the rover actually is, the flight hardware that's going to go to Mars. And before she left, I took this picture. Actually, it's a similar picture. We are standing over here in the gallery, and this is the hardware all set to go. The rover herself, the cruise stage, the descent stage, all the pieces that were assembled at JPL before sending the rover to the Cape to get ready for launch. And here's a picture of me right near where the rover is in the clean room. So this picture was taken at the end of last year. And being in a mask and a bunny suit was not something that I did every day then. And I'm just looking at this picture going, I'm wearing a mask right now. I was wearing a mask in that picture. It's become obviously much more common because this was before the pandemic. We shipped the rover, this is her container, to Florida in the middle of this unexpected situation of trying to launch to Mars while the Earth was fighting and is fighting off a pandemic. And suddenly we were in new territory. We'd never been in this position of trying to do a mission like this when we're working from home, when we're separated, when we're all wearing masks. When the rover got to the Cape, we added a plaque on the rover that says, thank you to the healthcare workers, to the essential workers that were keeping us safe and allowing us to continue with the critical work that we had to do to launch this humanity's mission to Mars. We launched on July 30th, and we did it with some of us working remotely and some of us working in person for the parts that had to be done. It was the first time that we'd been at JPL preparing for a launch, wearing masks and staying social distanced. You learn from the missions that go before you, but you don't, but this was new. This was not something that had been done before. We're now on our way to Mars. It takes 7 to 9 months in general to get to Mars from the Earth. And we have one team of people that is flying the rover to Mars and focusing on all of the maneuvers and preparation that we have to do to get the spacecraft from the Earth to landing safely on Mars. You heard Mimi say that she was at the launch of Curiosity, and folks might have seen the landing of Curiosity. Landing on Mars does not get any easier because you've done it before. We have sat through what CNN is called the 7 minutes of terror, where you come in the Martian, you come up to the top of the Martian atmosphere, and you fire the parachutes and fire the engines. So many things have to go right for the rover to land safely on Mars. And we've done it before with Pathfinder, Spirit, Opportunity, and other landers that we've sent to Mars. But I already feel myself getting nervous about when we'll be landing in February of next year. It's just as hard every time, and you never know what Mars might change on you. We'll be landing over here at Jezero Crater. You can see where prior missions have landed. And the idea is, where can you land that will try to answer this question? We have this big job of finding out, did Mars once have life? Collecting samples. Where are we going to go to do that? What's the best chance we have all over Mars of finding these nuggets of samples of information that we can analyze to see if there was once life on Mars? And Jezero was chosen. We've wanted to go to Jezero for years, but couldn't because it took a very precise landing. But we've gotten better and better at landing on Mars, and finally now we've learned to land on Mars well enough that we can go to this location that has such potential for finding out what Mars used to be like. We're taking an amazing suite of instrumentation with us, including so many cameras that I mentioned before. We have MOXIE, which is a oxygen experiment. For those of you who saw the movie The Martian, we're actually trying to make oxygen on Mars for the first time ever with this prototype instrument that will suck in atmosphere from Mars, which is carbon dioxide, pull it apart into oxygen and into carbon monoxide so that we have fuel for the return home in terms of the oxidizer in future missions, and also for the astronauts to breathe. And look at this. We have a partner this time. This is the helicopter. You'll hear more about this in tomorrow's talk, specifically about this amazing helicopter that we're taking with us. This will be the first time that we have ever flown outside the Earth's atmosphere. And it'll be wonderful to take this partner with us. She's right now on the bottom of the rover as she flies to Mars, and she'll be traveling with us at the beginning, scouting out what is ahead. Imagine the capabilities of a rover and a helicopter. But you'll be hearing a lot more about that tomorrow. So I'll let Sarah tell you more about that amazing part of our mission. I'll finish up by talking about what is it like to work on Mars, especially a mission like this that has so many different pieces to it. So this mission is actually the beginning of a campaign. Perseverance is not only going to take robotic samples of Mars, but she's the first leg in bringing those samples back to the Earth. She's the first step in something we call the Mars Sample Return Mission. So just like the astronauts on Apollo picked up rocks and brought them back to the Earth, we'll be doing that this time robotically. It will start with Perseverance collecting samples, putting them into very clean test tubes that we then leave on the surface of Mars. Another mission will come back and get those samples, stow them into a lander, and into a return capsule. So that Mars ascent vehicle, we will launch a rocket from the surface of Mars and return those samples to Earth. This is as hard as it sounds. Many pieces have to happen correctly for us to get these samples back to the Earth. And it will involve multiple nations from around the world all sending missions to help us return these samples. We hope to have samples back as soon as 2031. So we will arrive there next year, spend our few years collecting samples. Then the next mission to go back and get them will launch in 2026 and hopefully return our samples to the Earth by 2031. You might say, why do we have to bring them back? Well, that's because we're actually looking for signs of life. And we need all of the brain power of the world and all of the scientists and all of our capabilities to answer that question of, was there life on Mars? So we want to bring samples back to answer that question here. But we're doing that in an environment that we haven't before. Curiosity is still on Mars exploring. But for the first time, her controllers are entirely at home. This is the first Mars rover ever to be fully remotely operated. The engineering team and the science team, everyone's at home. And we had to learn how to do that, and we had to learn how to do that quickly. But now we are doing that as well on Perseverance. This room is actually downstairs in the building that I'm in. This is what our downlink mission control room looked like before the pandemic. Now, for Curiosity, all of these people are at home. For a mission to learn to work remotely, one of the advantages that Curiosity has is the team has been working together since 2012. This is different for Perseverance. We're at the beginning of our mission. We're just getting to know each other as a team. We've actually never all been together. And here we are working remotely. So what's actually happening right now, today is the last day of our first operational readiness test for landing on Mars. And that's where I have to get back to shortly. And this is where we're practicing with part of the team here in this building or the building across the street and part of the team being remote. We don't have the advantage of having been together and meeting each other and learning to work together. This is brand new territory. How are we going to do this completely remotely? Curiosity has been on Mars since 2012, and her team, like many of the teams of these exploratory missions, is made up of people who were there from before the mission launched, like myself, and people who are brand new. We have very young engineers on the team who were literally in high school or middle school when the rover was being developed and launched. And she's lasted so long that now some of these engineers actually and scientists actually grew up, went to college, got their degrees, came and joined us, and are now helping to operate this rover that they saw on their screens when they were in high school. It is not one group of people that does this. We hand off to each other and to the new engineers and scientists that come in. These missions are generational when we are lucky to have them last this long. I started out at Cornell University And then I went into the Air Force. As Mimi said, I knew from when I was a teenager that this is what I wanted to do. I wanted to do something that brought people together. And I saw this in shows like Cosmos. And I realized that it's the robotic missions that go so far. When I was growing up, the astronauts were in the Earth Moon system. But I saw that it was the robots that were going way out into the solar system. And I wanted to be a part of that. So I got my engineering degree from Cornell University and got space operations experience in the US Air Force that helped me get my dream job at JPL. And it's hard for me to believe that I've been at JPL for over 20 years. I kind of go, how did that happen? And then I look at these missions and go, oh, yeah, I was on that mission for 4 years and this mission for 5 years, and bam, suddenly it's been 20 years. But what I find the most rewarding is working with a group of people to do something that matters, to do something hard, and most of all, to know that the reason we're doing these missions of exploration isn't for our state or our city or even our country. These missions are for all humankind. And whether it's the observatories in Hawaii, whether it's missions that are launching from the US or from China or the Middle East or India, this is global exploration. And that's what my 14-year-old self wanted to be a part of. And that has been as rewarding as I always hoped it would be. I am very privileged to be a part of this, and I hope that we will have a chance to talk here shortly about your dreams and what you're interested in doing, because it doesn't have to be this exact industry. There's so many problems to solve, and there's so much that we need everyone to contribute to. So study hard, work hard. We need you. Come join us. Thank you very much.
Thank you so much, Nikki. That was unbelievably awesome. I feel so revved up after watching that presentation. It's so exciting the work you get to do at JPL, and I can't thank you enough for sharing it with us. Clearly, the other participants who were listening to you were just as excited as I was, because we have a variety of questions we're going to pass along your way.
Excellent.
Friends are just joining us. We are here with Nagin Cox, who just talked all about her experience working at NASA's Jet Propulsion Lab, working on some of these robotic missions to Mars and to explore our solar system. Now is the time for all of your burning questions. So feel free to submit your questions into the chat windows. And of course, we do these types of events to help you guys. We want to know how we can help support you and your careers for some of our younger participants tuning in. So if you are aspiring to work in the aerospace industry, please include the hashtag WiSE when you submit your questions, so we can make sure you get a priority. We really want to hear from our younger participants looking to join the field. So as we wait for some of those to come in, I'll turn to the ones we already have. And my first one actually is one that Nagin, you touched on a little bit. You showed us this generational photo of folks who've worked on many missions at JPL, and you showed us like how over the decades we've had an evolution of rovers, and you said the words that we don't do things alone. And I think, unfortunately, there's a misconception in science that a lot of people are isolated and are these super geniuses working alone. And your presentation very clearly showed the opposite. And I guess I'm curious for you, is this something you always knew about science and engineering and STEM fields? Did you always know that success lied in collaboration, or was it a surprise to you that you found as you found yourself working in the field?
You know, I think that, thank you for that question, Mimi, and I do want to say, thank you to WiSE for the opportunity to share some of these stories with their audience, as well as all the work that Pisces does throughout the year. For me, I think because when I was growing up, I saw the end of the Apollo missions. And so I was seeing, and for the space shuttle and the space station, they tend to show the mission control rooms. And that's still the case. So I would see teams of people, and there are now more women than there were at that time, but I would see these teams of people gathered around monitors looking at these amazing images or talking to the astronauts. And so I still had that conception that, will I be wearing a white lab coat and kind of be in a lab by myself? Will I be sitting at a computer by myself? But it helped that I could see that at least some of the time that folks were together as a team. And the further I got into that, whether it was being in the military space program or coming to JPL, the more I realized that the time spent alone is actually far less than the time spent together. And that's partially because these problems are getting more and more complicated, more and more difficult to solve. And in fact, when I go out to hire engineers for JPL, I'm not looking for that person who can kind of sit alone in their office in their cubicle or their computer lab and think and try to do it all themselves. I'm actually looking for the people who can communicate and be a part of a team and exchange information because these missions are too complicated for one person to keep them all in their head. So communication is the key. And that's why this pandemic has changed things so significantly, is because it's changed how we communicate. And that is the glue that holds these missions together.
Absolutely. It's really incredible to see you guys pull off the Mars 2020 rover in the midst of this pandemic. And I can say I found it very humbling to see that you included a plaque that recognized that you were doing this as a result of the support you received from all those folks on the front lines who are helping protect us and keep our country safe. So that's incredible. Congrats to not just launching this next rover, but doing it in the midst of a global pandemic, which can't be easy, of course. So actually jumping off of that, I'm going to ask you a question a little bit more about career exploration. We have so many questions coming in about details about the mission, about Mars missions, future ones, past ones. So we'll get to some of those. But we have a couple questions about folks who, like you, know they want to work in space exploration. So we have one of our participants who says, hey, I'm in high school. I want to know what I can be doing now to get involved. And we have someone else asking about degrees. What degrees would be useful if I want to do the kind of work that you're doing?
Great question. So let me answer the one about the degrees first. People also, when we talked about, will I be in an office? Will I be by myself? People do tend to think of NASA as being, or SpaceX or the space business as being scientists and engineers. And while that is true, that most of us are in that area, I do want to point out that, it takes a village. We have so many different kinds of people that make up the NASA family, right? It's not just scientists and engineers, it's also business people and financial people, and we have lawyers and we have artists and we have historians. And of late, actually, I'm working with more folks now that we have GUI designers and visualization, and again, the things that help us communicate. So when we talk about the degrees, we literally, folks can be from all kinds of backgrounds, but the most common is science and engineering. On the engineering side, it might be easy to say, oh, shall I be a mechanical engineer or shall I be an electrical engineer or an aerospace engineer? And the reality is, unless you're interested in a very specific thing, the key thing is to get that technical background, to get the problem solving background. When I'm talking to another engineer or we're talking to a scientist, we're not always talking about our exact expertise. Instead, the way we're communicating is between groups of people who know how to approach solving a problem, because you can't predict the problems. Every mission, it's different questions, different problems. And, you know, Well, bam, suddenly you're trying to solve the problem of how to launch in a pandemic and how to land in a pandemic. And in those environments, we treat that problem like any other problem. So problem solving, which you get with a technical background, with a STEM background, is more important than what that exact degree is in. On the question of what can you start with at the high school level, we have found that hands-on experience makes a big difference. In college, it's all about internships, right? About getting a chance to try your hand at this field and see if you like it and see if there's a fit. Same thing in high school. I've seen amazing robotics clubs. And it's not that they're robotics clubs so much as it's, again, an environment in which you can work together with a group of people to try something that's challenging that has a particular deadline. So, team building skills are something that you can start before college, whether it's being a part of a sports team, whether it's being a part of a robotics club, whether it's doing theater. I mean, if you think about it, doing theater is a group of people working together to do something hard by a deadline, right? So building the teamwork skills is something that will carry you through and be a very strong partner to the technical background. And if you think of the math and science, that's like a language that we all have in common, that we all can speak as a common background. So there's lots you can do now.
And I think that's really important to emphasize and to share, right? There's so many ways to get involved in this industry. There's so many STEM degrees that will help you. And even if you're more excited about another field, that doesn't mean you can't be involved in space science and pushing forth our humanity's understanding of these strange worlds, right? You can get a STEM degree, you can do it. You can be in education, work in communications, you can do it. You know, we need all kinds of people who are helping us in aerospace. And Niki, I think you really spoke to that very well.
And I want to mention that there are more and more science communicators out there, people who have a technical background and consider it a really big part of their profession to share that information. Science literacy is something we should all be literate in science, whether we're in the field or not. And so this area of science communication is so key because it bridges the world of those who are in science and math and those who are not. And since we're all in this together, I can't think of a more critical field that's right next to the actual science and engineering. They need to go together.
Absolutely. All right, Nagin, if it's okay with you, I'm going to transition to a few questions relating to actual planetary science and about how you design these missions. So we've gotten a couple questions about specifications for these rovers, how you send a variety of rovers and you keep updating them. And so we have a couple questions about the tools. Why not have a robot that can dig? Why not have a drilling robot so you can find water underneath? So could you maybe speak to how your team looks at the past rover and they decide what should be on the next rover, which tools it should have?
Oh, what an excellent question. In fact, I had trouble making myself go over that slide as fast as I did.
Great.
So we do, in fact, this rover can drill, the prior rover could drill. We carry a suite of instruments that, and so this is just such a great question because it highlights why we have to bring samples back. So when we send a rover, like in Spirit and Opportunity in 2004, we formed a question. Was there ever water on the surface of Mars in the past in a liquid state? That was our question. Then we said, hey guys, that's the question this rover is going to answer. And we threw open the doors to proposals from universities and institutions around the world and said, this is the question we're trying to answer. Raise your hand and send in your proposal if you think you have an instrument that will help us answer that question. So then we select our payload, our instruments that we're taking with us on the basis of, okay, if we take 2 cameras and 2 spectrometers and a drill and a microspectrometer, if we take this set of 8 instruments, because we can only take so many, that'll give us the best chance to answer this question. Then we answer that question. We answered it successfully. Yes, there was water. And then we were like, oh, now we're going to have to answer the question, how long was the water there? And so you do the same thing for the next rover. And we said, you know, we're going to have to drill for this one. So we took a drill with us. But separate from ask a question, build a rover, ask a question, build a rover, what we found is kind of the minute you land, the minute you get there, yes, you're trying to answer that question, but then you think of another question. And so the questions were coming at us faster than we could answer and build rovers to answer the new questions. So in the end, the biggest question of all, was there life, actual life, microbial life on Mars in the past? That question is so big with so many smaller questions that we said, you know what, we can't, you can't build a suite of instruments that will answer all those questions. That's why we have to bring the samples back, because then we have them on Earth and we have all the questions we can think of and all the instrumentation here on Earth. And then we can use the brain power and the instrumentation of the whole planet to try to answer this biggest question. As Carl Sagan said, extraordinary claims require extraordinary evidence. So your guys' question was perfect. How do you